The fact that we have exponentials motivates me to use the weighted AM-GM inequality, because the standard one won't be enough, right? Of course, they're all positive numbers. Here, I just use A, B, C, D as the A's, also A, B, C, D as the B's, right? So in this case, I always have this inequality, right? A plus B plus C plus D. The A1 times B1 is just A times A. A squared, likewise B squared. C squared plus D squared, always bigger than or equal to the A plus B plus D. A, B, C, D. B1 to the A1 is A to the A, then B to the B times C to the C times D to the D. Right. Of course, A plus, they add up to be 1. Right, that's given. So I always have this inequality. Right, that's also 1, so that no problem. A to the A times B to the B times C to the C times D to the D. Right, this is always true. Right, so in order to achieve this, I multiply both sides by this bit, right, and change the direction of the inequality. A plus 2B plus 3C plus 4D times this bit. A to the A, B to the B, C to the C, D to the D. Less than or equal to A plus 2B plus 3C plus 4D times this bit. A squared plus B squared plus C squared plus D squared. Right, somehow I have this. Right, this is always true, following that. So to show this is less than 1, can I show this is less than 1? Right? Loosening the inequality. If this is true, then that's automatically true. Right? But 1 can be written into, that's given, right? They're sum. Right? But the fact that these multiply out give us polynomial of degree of 3. So I can rewrite 1 into their sum to the power of 3. It's the same thing. Right? As long as I can show this is true, then we're done. So can we show this inequality is true? Right? If we can, then we're done. So left-hand side is equal to what? Of course, distribute this onto the whole piece, right? A squared. A plus 2B plus 3C plus 4D plus distribute B squared onto the whole thing. B squared, same thing. A plus 2B plus 3C plus 4D. Likewise, C squared multiply A plus 2B plus 3C plus 4D. Last, D squared times A plus 2B plus 3C plus 4D. Right? So right-hand side. Right? Of course, after expanding and regrouping, long story short, finally we reach, likewise we take out A squared, factor that out. Right? A plus 3B plus 3C plus 3D. B squared. 3A plus B plus 3C plus 3D. C squared. 3A plus 3B plus C plus 3D plus D squared. 3A plus 3B plus 3C plus D plus 6 ABC plus 6 ABD plus 6 ACD plus 6, BCD. Right? Notice all these terms, right? These terms are strictly positive, right? Given it's true. And so pattern here is that if it's a squared, then the coefficient of a is just 1. Right? If it's b squared, coefficient of b is just 1. The others are just 3's. Right? So as long as we can show this is less than that, strictly less than that, then we're done. Of course, like at both, we have a squared. Right? Can we show this is less than that? Less than or equal? Likewise, can we show this is less than or equal to that? This, is it less than or equal to that? This, is it less than or equal to that? All right, so this, to show this is less than or equal to that, we use this minus that. All right, what can we get? So this minus that. So a minus a. 3b minus 2b. B. 3c minus 3c gone. 3d minus 4d minus d. Can we show this is greater than or equal to 0? Okay? Of course. B greater than or equal to d. Of course, true. Likewise, we use this minus that bit. Right? Looks like we get, what do we get? 3a minus a, 2a. B minus 2b minus b. 3c minus 3c gone. 3d minus 4d minus d. Similar. B minus d. Here the only difference is that a minus b then plus a minus d, right? Look at this and look at that. A minus b definitely greater than or equal to 0. Right? Likewise, a minus d, same thing, right? So really, this is really bigger than that. So that is less than this. Right? But likewise, so these minus that. So this, same thing, right? This minus that, right? This minus, same reason, right? But in the end, we want to show it's strictly less, right? Because the equal sign may still hold, right? But luckily we have, remember we have this. This is why it's strictly less than. Like I said, right? All of the numbers are strictly positive, right? So definitely, right? Even if equal sign holds for everything, right? This, but we still have this. That's strictly positive, right? So this whole piece must be strictly less than this whole piece, right? And we're done.